We're continuing from the previous slide. Here we go. We talked about placebos. A placebo is a dummy treatment that looks like the real treatment but doesn't have any of the active ingredients. When a placebo is used, we say the subjects are blind to treatments. That's because they don't know if they got the active ingredient or not. And so that makes them all respond equally, at least in terms of the placebo effect. They've all been treated equally, so they all have the same response to being treated. And some of them have the active ingredient and some of them don't, so maybe the active ingredient would cause a different response. If they're blinded treatments, we call the experiment single blind, meaning one group is blind to what is happening, the subjects. And if in addition the experimenter does not know who got what treatment, the experiment is called double blind. So that's advantageous because then the experimenter, or at least the person recording the information, isn't biased by knowing that who had received the active ingredient and who didn't. So if you're, for example, trying to see if the COVID-19 vaccine is working, and the experimenter knows who got the real vaccine and who got the fake vaccine, and they're recording the symptoms that they see in the patients, they may be less likely to report symptoms of COVID in the ones that got the actual vaccine, and less likely to report them, at least unconsciously even, for the people who got the placebo. Of course, at the end of the study, the treatments are revealed. You need to know who got what to analyze the experiment. So they would perhaps assign subjects treatment based on choosing an envelope with a number on it. The number is recorded somewhere else that says what's in that envelope, whether it's a placebo or a real treatment, and then during the course of the study, everything is related to that number that was on the envelope. And then at the end of the day, they look at the table and they see who got what, and they can analyze the results and see what was reported for symptoms and things like that up against that number. And then they can see if that number was the drug or was the placebo, and they can analyze that. Experiments can benefit from two things. One is replication. Use many subjects. What we're trying to do is to, we're worried about random variation, I guess. That's how I want to say this. So we want to reduce the impact of random variation. So you can do that by using many subjects, and that way the pluses and minuses in those subjects tend to cancel out. If you have a lot of subjects, then you get an average that's more stable if that's what you're measuring. And then randomization, apply the treatments randomly. So we say, so we'll do that across across all subjects, let's say something like that. Sometimes you've broken the subject into groups, so across all subject groups, I guess. So once you've identified the groups that you're going to compare, say you've decided to study heart medication, and you know men and women respond differently to heart medications, you would break your subjects into men and women. And then you'd apply the treatments, the different kind of heart medications, randomly across that group of men and randomly across that group of women. And the reason for doing that is you don't want to artificially, say, apply one treatment to a certain set of individuals that's different from another set of individuals in one treatment group. You'd like them to be as homogeneous or as similar as possible. So once you identify the things that you think might have impacted the response variable, like gender, so you separate them by gender because gender might impact the response variable, then for each gender you will apply the treatments, the different kinds of medications randomly to that group. So two things you would want to do is use replication and then randomly assign treatments once you've decided you've tried to control for other explanatory variables by breaking them into groups. So here are the steps in designing an experiment. It looks like designing a survey, pretty much. It says, identify your research question and determine the explanatory variables that you want to study. So Ordinarily, that would be, say you're talking about weight loss or something. You might the factors might be what type of exercise the person does, what kind of diet the person does, and then maybe there's some kind of weight loss supplements you might be able to take. So you might have 3 factors: supplements, diet, and exercise. Those are the factors. Determine the number of experimental units. You might have to consult with an expert there, because the number of experimental units depends on how big you think the response is going to be. If you don't have enough units, you can't see the response, because it might be buried in this random variation between subjects. People are different, they respond differently. And that might be a big part of what you're looking at. And so if that's true, there's a lot of variation between people and their response, then you're going to need a lot of experimental units. Identify the levels each factor and control for factors not studied. So you're trying to decide, well, if you're talking about exercise, diet, and supplements, what do you mean by exercise? You're going to have to decide what you mean by levels of exercise. A diet, what kind of diet? Are you going to just study the caloric intake, or are you going to study the type of diet, vegetarian, paleo, whatever it might be? What factors are you going to use? And then what supplements might you be thinking? And then how would you then decide on treatments, which is the level of each of those factors combined together to study? And then how do you control for factors not studied? You might have things that you can't control for, and you don't have enough subjects to divide them into groups. So you could divide your treatment group into men and women, or old and young, or fat and thin. But as soon as you get all those things that you think might impact the outcome, by the time you narrow it down and try to put those subjects into groups, there might just be one subject in each group, and now you're just back to square one. So the control for factors 2 ways. One is to break the subjects into groups where they have similar levels of a possible explanatory variable. Okay. That's one way. And the other way is just to make sure you randomly assign the treatments across those various levels of other explanatory variables. So that's that randomization part. So that's complicated. And you have lots of options there. And what you get to do depends on your size of your experimental group, and also what things you can actually measure. There's things that you might not measure that if you could measure, would help you decide what's happening, but it gets too expensive, or there's just too many variables that you can't break your subject into groups based on all these variables, because then each person's in one group, and then you can't study what it does against a comparative person. Go ahead and conduct the experiment, okay, and then analyze and report results. And of course, as we said with surveys, you want to talk about limitations. So you want to say that in context and state limitations. So at the end of the day, you want to just give a summary of what did you find and how sure are you of what you're concluding. And that comes to the end of this slide. We're in section 1.6 still. It's about experiments and a lot of definitions. In a minute, maybe we'll be able to do something that's not just write words down and talk about them. We'll just see what happens.